So yeah, the name of this talk is Remedies for Backbone, Scaling Backbone.js at SoundCloud. Caveat, it's obviously not going to solve all your problems, but it's kind of a look at how we solved several problems and just some kind of like best practices and things that really helped guide us build our large single-page app. So yeah, I'm Darrell Stephenson. I'm a front-end engineer at SoundCloud. Most of the engineering is actually out of Berlin. And as far as professional credentials, I guess I had enough to work on a production app there. So that's more than I guess necessary. If you guys have any questions, just ask me on Twitter or I'll be around. So yeah. So some quick assumptions about this talk is that you already know what Backbone.js is. It's not going to be a talk that really is introducing the kind of standard patterns or what a model or collection in Backbone is. So if you're not sure what Backbone is, you're probably in for a bit of a weird ride. And I'm hoping also that you have some kind of awareness of single-page application patterns. Maybe you've been kind of keeping up to date with different blogs, and you've looked at kind of competing libraries and code bases. So what are the pains that we're going to talk about here? The first one is this boilerplate issue that a lot of people come across with Backbone. The pain of using a public API. I think this was specific to our case, but I know this is kind of like a trend in a lot of companies who are using single-page applications. And when n gets big enough to flip tables or cause frustration or however we pronounce this characters. So current scale at SoundCloud. We have 30 million registered users and growing. 10 hours of audio are uploaded every minute, so we have a lot of activity on the site. And our single-page app has been our default production app since December 2012. Obviously, it's been a lot of work before that, probably I'd say about a year of development, first with a proof of concept, and then after we had a beta program for about 6 months, and finally went live with it on December 12th. So yeah, and as far as lines of code, it's about 37,000 lines of code currently, which I guess in the scale of really large apps is actually quite small, but for JavaScript apps, it's quite large. And 80% of that is JS. So just to kind of give you a mental picture of what kind of things we're interacting with a lot, it's really heavy on JavaScript. So this is what our homepage looks like. Who here has used SoundCloud or know what it is? OK, awesome. So I don't have to do too much explaining, but the purpose of showing a lot of these views is that we can see that these are all kinds of like different views within SoundCloud, all within the same app. And so this is a stream page. So for logged in users, they get basically a news feed of sounds coming through. My play count is super sad, so check out my tracks. And also, we have these kind of listen detail pages. So first, this is like the obvious question when people always ask, like, what's your stack like? What are you building on? So Sound Manager 2, I guess, is really like the core of SoundCloud currently. I mean, you can't have SoundCloud without sound, obviously. This is an open source library. It is basically a bridge between Flash and HTML5 audio. It uses, you can do a lot of different configurations to say choose HTML5 or choose Flash. And given a lot of the current standard of HTML5 audio, it's really good to have this kind of Flash fallback because certain pieces just aren't there. The triumvirate of jQuery, Backbone, and underscore. We use handlebars for our templating with a lot of helpers. It's one of the really great things about handlebars is that you can write helpers for it. Require.js we use in development environment. So basically to keep code fresh, to keep line counts exact. So when you have an error, or you set breakpoints, you know exactly where it is. And then there's Almond.js, which is a lightweight loader that we put into our build when the app is getting built out to production. They're both, like I said, these are links to them. You can check out these slides later. Yeah. And of course, we use Node.js, but only for our build and tooling. So really to compile, there's a bit of kind of like AST walking and some other fun stuff, but yeah, there's no kind of production servers hitting Node. It's just really for tooling. And then we have homegrown deployment tools. I really wanted to include this part because I think it's just as important to have super strong deployment tools when you're doing a JS app to keep the kind of feedback cycle when you're working really fast, and you kind of can get fixes out or respond to user feedback as fast as possible. If you want more info about actually like the stack implementation, we wrote a blog post I think about 6 months ago. It's called Building Next SoundCloud. There's a link there, and just Google for it as well. It's got a lot more of these, like I said, these implementation details about what is kind of going on at a foundational level. Yeah. So on to the first one, which is boilerplate. So here's a quote. This boilerplate is the product of much research and frustration. This is a Git blame from the README of Backbone boilerplate, which is actually an open source repo that is kind of aimed at solving this issue that is a common problem to people using Backbone, is that they feel that there's a lot of boilerplate. It takes a lot to get started building an application on top of it. This is like, I just wanted to have this quote in here to really show this is this kind of common issue to building an app on top of Backbone. So what exactly is the boilerplate, though? Well, first of all, Backbone is this small, compact library, and it has a couple key concepts in it. But like I said, it's a small library. You can actually sit and read the code and put most of it in your head in a single reading. So a lot of this is actually just building an app. I mean, when we think of boilerplate, it's not stuff that has to be repeated. This is stuff that we can actually, automate away and abstract away as well. So a lot of this is just building an app on top of a library. This is not a framework that is going to put you out and you're going to be writing apps in 5 minutes and everyone will be happy. Then there's also the workflow and environment, which is build tools, file creation, file watching. These are super important to have as a really strong base in your project, obviously. You need to be able to iterate fast, and the better your development environment is, the better kind of code you'll write, because you're not struggling against some extra thing. And then there's kind of some boilerplate that comes from application internals, which is basically sharing model instances across views. Especially when you keep your code modular, sharing these models between views is a problem that Backbone doesn't offer a solution for. And really writing a modular view system. Backbone is least opinionated about views. So basically, the models and collections, the kind of what you get there is pretty tight. It's pretty kind of simple to use and understand, but there's a lot of ways to do views. So most people, I think, when they go to build an app, and they see that they have all this like boilerplate, they're like, oh shit, like now I have to do all this work, I have to actually like work on an application. I can't just pull different GitHub repositories and have something out tomorrow. And in hindsight, this should be really obvious, right? It's like you're building an app on top of a library, and you're building an app with a lot of user interface elements on top of a library that isn't really giving you a lot to deal with views. So clearly, this is this kind of thing, and I think it frustrates a lot of people, and maybe they go running to another framework really quick. But what you really should be like is like that. where you're just kind of like, all right, you know. The main reason is because you actually get to make these opinions for yourself based on the specific use case requirements of your application. So, you know, there's two ways to look at it, really. It is extra work, but it's work that pays off in the end because you have a system that is more for your own use case and that doesn't really get in your way at all. So if we were to look at the balance of how models, collections, and views in our code is, we have about 33 different models, 48 collections, and around 200 views. So it's clearly, I mean, you show that when you're writing one of these apps with a lot of features and a lot of different elements, it really trends towards a lot of views. You're going to be working in the views more than anything else, and actually writing kind of the interaction in the view a lot. You know, and this makes sense. If we look at how an app breaks down, you know, in the red I've highlighted what kind of separate views are. So play button is its own view, badges or titles are its own view, waveform, the waveform comments, etc. Basically everything that can model data, can respond to change data, or can basically have any kind of interaction, this constitutes a view. So, you know, also because many will represent the same model or the same collection, we start trending to really kind of project gets loaded up on view code. So modular views. You know, this is clearly I think the most important thing that I need to stress about scaling one of these apps is that you really need a strong modular view system, and you need a modular view system with a lot of opinions, because also the library that you're using doesn't make a lot of them. So really, they need to do a lot of things. Modularity is not necessarily, you know, you want it to be self-sufficient, really, and within this kind of system, they have to do a lot of different stuff. They have to render their templates, mutate data before rendering in case what you're getting from the server needs to change a bit, or maybe you're pluralizing things or whatever before it goes out to the template. They need to establish a data source, communicate with the model, of course, manage their own visual states. This is important too. You know, we have to maybe apply CSS classes to the view or alter the view in some other way to respond to state. Set up and tear down event listeners. Recently, this is kind of made easier in Backbone, well, the last two versions, really, version changes. And, but yeah, you can also set up other views or other events yourself that you'll need to tear down later. Caching template elements. This is really important, so we're not doing expensive DOM lookups all the time. And we need to respond to, of course, the DOM and other events. And last, we need to add or remove subviews. So we really want to have a composable system where we're adding or removing subviews. This is super important, again. And really the goal when you're writing your view code, especially your foundational view class, is to make it modular. In our project, it's a bit hard to see, but the including a view is really as easy as including a handlebar helper and a template with a file path and a resource ID. And really, I think this is as simple as it should be, because any other kind of view instantiation, if you're doing it in different ways, as your project grows and people do this in different ways, your code starts to get really messy. So strong opinions here are super important. So obviously, this is how you would include one. This is kind of an implementation of a simple view. We're writing in CommonJS module style, which gets converted later during a build step. But again, it's very simple. We require group, which is our model. We require the base view class that we're using. And then we apply a class name. We include the CSS from the view, include the template from the view, declare our model class so that our base view class can instantiate it automatically. And then we have required attributes. And these are important. So these two here are important because the views need to know when they have enough data to render. And so automating that away or making that kind of interface as simple as possible is super important. So we can declare an array of different properties that we need to check after a fetch has been made to make sure that, this is all we need for this view. Let's render. If the model changes and say one of these observe attributes changes, then maybe we re-render. And sometimes we don't even put required attributes, but we'll have an observed attribute, say for something that's empty, and then this property comes in, then we will actually put the view into place. So really, given this kind of shift where your app gets heavier and it adds a lot of views, the view really is the most important class for code growth. It's going to be the most used, but it's the least built out already by Backbone. Solidifies a huge amount of shared behavior. This is also super important. Done properly, this is going to save you bytes in the long run and keep your application thinner because you're not reduplicating. You have kind of your foundation is providing a way to avoid repeating yourself. And I think this is really the most important thing about this as your project grows is that how you include that and how you program that base view class is really what codifies convention. And having convention and strong opinions is really what will help your app grow. There's not, if you have these conventions in here and you have these really strong opinions at this level, there's not a lot of kind of concern when you're working in a team of other developers about how to implement something. The patterns are strict, they're easier to follow, and it removes a lot of the worry of those kind of things. So just to sum up this, boilerplate is really building an application foundation, especially when you're building it on top of a library. Focus time and energy on getting the base view class right, and really as much as possible. Yeah, it's that. So on to using the public API. So dog fooding. This term kind of exists, I guess, in the tech industry. And if you go to Wikipedia, you can kind of see this history of dog fooding, where I guess there was a commercial about someone feeding food to their own dog or something like that. Then it became some buzzword circulated in 80s Microsoft. And I heard this a lot, and I'm sure you all have. And what this really means is like using your product the same way a user would. And this is really about, if you use your product the same way a user would, you can experience the same frustrations, but you also have the power to go back and kind of solve these frustrations. But it sounds weird, right? Like, what if I told you I eat dog food? I mean, this idea that we're eating dog food, I think, it's kind of bizarre. And I think that, if the goal of this is really to ensure like high product standards, surely there are other ways other than doing exactly this way. And it's kind of a funny story that I know it's like my second day of working at SoundCloud, and I guess we had a phone conversation with Dan Webb from Twitter, and he was like, this single page application approach, like, it's not working out. And this is like 6 or 7 months into SoundCloud building out this single page app that's using the public API, and he's like, it's just not going to work. We're transitioning a bunch of stuff back to the server, and like doing so, we found we've got a lot better results. So of course there's that worry, and you can read the blog post about it. But again, like you have to think like, what is your use case in these scenarios, and not get like so cargo cultish about these things as well. Like really think like, why would you dog food? Why would you use your own product in the same way? Are you really using it the way other people would? I mean, clearly there's other ways to maintain high standards, like metrics. I mean, attaching metrics to your app is a really great way, of course. Contractual agreements. If you really want to have, the highs, basically standard, legally binding is pretty good motivation. Face-to-face with builders, understanding your users. So talking about the good things about public API, the data is there in a lot of cases. Like you're already offering it to people. So when you start going down the approach of a single page application, you're not being blocked at all. There's no services to build. It's already handling a large amount of traffic. It's there. It's usable. And it has probably a lot of what you want. Concentrates common business logic as well. So if you have, the desktop site and the mobile site, and then maybe you have your Android and iOS clients, or different clients can consume your API in the same way. And of course, once you start putting this into production, it demands high availability, low latency, all the kind of features or things that you would expect from a reliable service. But the bad stuff is really that it's far too generic to be performant at scale. And I think this is a really huge thing. And also, it's inflexible because of external obligations. Once you have built something like this, and you have a public API, and people start using it, you want it to be stable. You want it to be fixed. You can't mess around with the properties as much because other people are depending on this as well. So you have this kind of unspoken contract most of the time to serve people a quality API. So for an example, this is a standard playlist JSON representation that our API would serve. And you can see really that there's a lot of properties on here. I mean, we're giving basically any consumer of this API all of the data because we're not actually sure what they're going to build with it, right? I mean, you're serving a bunch of stuff so that people can actually use it. So we're including other kind of submodels as well. So like I said, that idea, it's too generic. So what we really would like is actually, I think that my slides got out of sync somehow. There we go. So what we really would like is a playlist representation that looks like this, that is short, succinct, it's to the point. It's what we're going to need for basically our app Chrome that is in the client. And you may think, okay, well, these JSON representation, the difference is probably not that big, especially when you factor in latency and going to the server, et cetera. But if you're doing this thousands and thousands and thousands of times, and even you want to load hundreds of these into the client, then it does make a difference, not just in sheer data or sheer throughput of JSON, but actually parsing the JSON as well into a Backbone collection. So it's really good to get specific with these things. So again, when your data source is inflexible, you start running into problems. And what happens is the client code gets the brunt of it, because you can't shift the code on the API, but we have this client app out there that we can actually put some kind of logic into. But you start adding more complexity into it because you have an inflexible data store. And you start doing more expensive operations in the client, which is really bad. You don't want to do a lot of complex sorting, filtering. Maybe you want to kind of have a shuffle feature, for example. You don't want to overfetch hundreds of models to just shuffle a couple. You want some service that will give you 5 shuffled. And ultimately, you also start making more requests to the API, which is really bad in terms of performance. We want to make as little requests as possible, obviously. So for an example of this, this is a user profile. In the top, we have a spotlight section, which is basically it's an editable section that a user can adjust based on their desires. Maybe they want to showcase a couple latest tracks, etc. And then below that, we have just the kind of normal stream. So ideally, in Backbone world, this would break down into a single collection, maybe where the variety, the actual representation is different a little, and we could say, okay, put the spotlight items on the top, and the rest of the items going to the back, or at the bottom of the stream. But the problem was that they were actually two different data endpoints. So functionally, they work as a single collection. The design is to be functional as a single collection. But remotely, they're completely different data. So you start running into real problems sorting out how these are going to work on the client. Examples of this. So like I said, the cleanest implementation is really a single data object per view, per functional view. The design treats items functionally as a single collection, but the server providing endpoints for each collection. You start getting into complications in, is this collection ready? Is this collection ready? How do we know when to render? What happens if one has an error, et cetera? And then you start really freaking out. You're like, this is not how this backbone abstraction is supposed to work at all. This is supposed to be really kind of simple, actually, in that the server provides the data, it's a source of truth for our application, and we present that in a really nice way. So obviously, you have to get flexible with these services. Here's an example of a place where we have a completely separate service actually serving the data now. So we release a feature where pro partners at SoundCloud can customize the backgrounds of their sound to offer some more brand awareness. All of those images and that data is fed by a totally separate service. And it was really easy to work with. Similarly, we did the same thing for recommendations. It's actually through the API to avoid caching, but it's not like a public route or anything. And again, we were able to, from the start, map this into a really cleanly dividing representation from the server. Again, for the Explore page. And so after working with these three examples of situations where we were able to decide what the format of the data works with and be flexible and have fast iterations, it was like, this is a joy again, this is really pleasurable to work with. And this is really where the abstraction shines. If you're doing too much complicated filtering and overcompensation on the client, your app is not going to scale very well. You're going to really run into a lot of problems. So in summation, I really think that using a public API doesn't work well at scale. I know, if your app is on it, I would definitely say, try and move into flexible services that don't have external obligations as soon as possible. And it's all about having that flexibility, being able to bind or to kind of set up your representation and feed your client app properly. So comments on SoundCloud are a very special thing. This user is saying, SoundCloud user comments attached to songs are iconic and life-changing. And this one says, a special corner of internet hell, the inane comments on SoundCloud tracks. And I understand, it's commenting, it's commenting on the internet. But between those two mixed positions, it's like we have to support this. And obviously, it's something that a lot of people are using. And so that leads me to this point, is when n gets big. So n is just a kind of random thing, and n might be big at a certain level based on your use case. But for us, we've seen when n gets big, really in relation to comments. So this is Skrillex. He's a really popular dubstep artist, electronic musician. And this is just 3 sounds from the top of his stream. If we look at the counts for this, we have 1,265, almost 2,000, 1,612 on a waveform that respond to time as well. So if we think of these setup totals, we have about 4,800 comments just on those 3 sounds. And then just to kind of, complete some arbitrariness, not all of them we're going to show right away, of course. We have about, say, 15% replies and, a bunch of off-screen things. So in the Backbone app kind of model, you have this collection of comments and a template, maybe a loop on a template that would render these out. So the initial template-based approach for this, it worked fine on low counts, obviously. It was using a list item, you know, it just seemed like kind of a standard implementation. And we have actually this list view class within our code base that helps manage lists and insert things in the correct place. And you know, each list item, say, make about 4 nodes in the DOM. You have a list item, say maybe a link, an image, and a span, maybe to show or hide text. So now we're at 16,320 nodes, and we're just showing 3 sounds. So DOMs these days are pretty good. They can handle a lot of nodes. But Skrillex has 50 sounds, and we have infinite scroll. So as we're getting there, now we have, if you were to scroll from the top of his page to the bottom, we have 272,000 DOM nodes just from commenting alone. So common symptom of this is I'll snap, browser crashes, or if it didn't crash and you were somehow able to hang in there, it was really incredibly unresponsive. Scrolling was a real pain, and that whole user experience is ruined, basically. The whole reason we're building these single-page apps is to really have a concrete, awesome user experience, and we've totally wiped it out just, you know, putting comments in the DOM. So of course, you can do some kind of limit enforcing, where you say, hey, we're only going to show 200 comments per sound. But we still end up with about 40,000 comment nodes in a stream. And of course, there's, you know, some other tricks of hiding these things. But one of the problems with this implementation is that even if you didn't get the all snap, which sometimes you would, I mean, we're dealing with computers that have you know, higher amounts of RAM, lower amounts of RAM. Some people have other processes running that are taking up things. It still is not performant. And what's worse, you've actually ruined the reason you're showing comments in the first place, which is some kind of visual indication of the popularity of a track. Basically, all tracks over 200 comments now are going to look exactly the same. So, you know, you've done this. You've actually ended up with a still poorly performing product, and you've actually ruined the kind of design motivation for doing this. So, you know, there was a lot of thinking, and we decided to go back, we decided to say, back to the canvas, we don't need templates for this. Like, a DOM-based approach is just not going to work here. So we went with something which are actually loading all the comments onto the canvas. The beauty of this approach is now we have one node per sound that can handle an arbitrary amount of comments. And the initial memory profile barely changes. So, you know, it's kind of a really efficient way. I mean, it's hard to get more efficient in the way of DOM nodes of having more than just one per sound. So there's obviously no template in this view. There's just a reference to the canvas context. So we've kind of changed it a bit. But it uses the same patterns for collection events, which is super nice because actually working in that way, you're still within the Backbone framework of handling data and handling events on data. So how it works, we actually just preload all avatars, create deferred objects for each one, and put them into an array. We have a when all method. And so when all the comments are loaded in a single quick loop, we write them out to the canvas. And then, because Canvas is not that great to work with for interaction, you have to start testing mouse points, etc. We have some separate views that sit on top that are just very light ways to actually interact with the comments. But of course, like, you know, you're still making tons of requests, loading thousands and thousands of comments in this situation, which is also kind of crazy. So then we're like, well, let's go even further here. We're going to limit this to the last X comments, so the most recent whatever. It's a configuration variable that we can use. We're going to draw the last comment avatars, And then we're going to draw the actual amount of lines that we have in a repeatable way on the waveform. Which is helping us solve the problem of you can still get that visual information about which ones are ultra popular by looking at the waveform itself. So this is the before and after. It's a little hard to see in the slide, but the top one is actually loading all the comment avatars and drawing the lines out. And the bottom one is the optimized version where we just generate the lines to draw to create that information based on a single count property, and then the avatars are set in the bottom. So obviously there are some slight differences. They're definitely not as recognizable if you're not attending a talk about optimizing Canvas and how this whole thing is explained. But generally, this really serves well in getting us to this point where now we have an optimized implementation of comments on the waveform. And so you may be thinking like, oh, well, that's just a trick. You know, like, this is just a kind of a visual trick. And my response to this is, yeah, it is. And I'm OK with that. So obviously, in this case, Canvas is not some magic bullet for performance at all. In fact, like, you really need to decide where it makes sense. In our case, it works super well. I mean, this is a point where a template and a Backbone kind of collection and template thing just couldn't meet up to basically a scale need of having tons of nodes. But they're also kind of special in this case in that they're in a high density in kind of a small space, and it's highly visual. So there's no text, and the information is pretty easy to grab as well from just loading in the images. So I think the lesson here really is break out of the standard pattern where it makes sense. And that modular view system you set up, again, when you have it set up like this, you can break out of this pattern. And it actually doesn't take much effort at all to break out of this pattern. Our Canvas view is really basically setting the tag of the Backbone view to Canvas, and then we chain the context after we render it. And the great thing is that this Backbone's view opinion is flexible enough to support this kind of thing later on down the road. And it's really a kind of unexpected thing. So, I mean, when you have something in the base that doesn't make a lot of opinions about how views are refreshed or re-rendered, you really have the flexibility to kind of think outside the box and solve solutions in different ways. So a little more trickery. This is a playlist of 2012's best dubstep tracks. It's 10 hours and 14 minutes long. It's composed of like 170 different songs or sets. And it's hard to tell in this photo, but there's actually dividers in between every waveform. The design idea of this is to view sound not as, a list, but actually as kind of like a single waveform, This is one of the things that we're known for, and we really want to keep that kind of brand and recognition alive. So our standard way of loading waveforms before was actually to load an image and then draw that image out on the canvas. And then recently, we changed this over to a flexible service that actually just gives us basically a large array of 1,800 amplitude points for the waveform. So now we just have a JSON array, which is by far a far more efficient object when we want to just write things out of the canvas. But we're still, in a use case like this, making 180 fetches or whatever, 180 requests to get these waveforms. But if you look closely at these waveforms, there's actually, these are all the same waveform, or at least these ones here are now the same. Well, those are the ones you can recognize. Actually, this whole waveform in itself is composed of pre-selected, kind of randomish looking waveforms. And and then we just write that out from only 5 files or so. So don't tell anyone that. But obviously, it doesn't make a difference in that sense if we draw the whole waveform out, right? Like people can't tell. It's not the point to analyze the waveform in such a small context anyway. So really, if the view is compressed into a very small space, just draw a fake. Choose from a pool of pre-selected ones, possibly cached on the client. The page is much faster. At that kind of level, you can't tell anyway. Everybody wins. So the lesson learned here is really illusions can go a long way. And I think that, I mean, it sounds funny. It sounds like, hey, we're tricking people. But if we think of so much of our best practices in front-end development, there's actually a lot of that. I mean, and it's not just substituting out waveforms. We're loading HTML into the window so we can have something to render before the JavaScript loads in to bind it. And a lot of what we're doing is kind of hacking visual perception. And I think at scale, a lot of these things work incredibly well. And the whole reason we're doing this is really for this user experience. So yeah, conclusions. A strong modular view system is really, I think, one of the most important keys to growing your code base gracefully, especially when you're basing it on a Backbone library. Public APIs are inflexible, and they can put the burden on the client. Use flexible, specific services for your production application instead. Don't be afraid to ditch the standard view. Canvas solves certain problems extremely well. And sometimes an illusion is as good as the real thing. So, thank you.
My question's about when you were building this view system, did you look at any of these other third-party libraries that build on top of Backbone and draw any conclusions or see any promise in any of them?
Yeah, I mean, I think that when we first started out, I mean, it was one of the first things that you have to build when you build these applications. And I think that at that time, there wasn't a lot of super well-developed ones. While I was writing this talk, I recently went back through and I looked at Marionette. And it looks like it has a lot of the same ideas. I haven't used it, so I can't say if how well it works, but it seems like it has a lot of the kind of pre-built modular view kind of composable view system in place.
I have 2 questions. First is, how are you handling internationalization? And second is, are you rendering on the server, or are you sending down empty pages to the client?
Yeah. So first question of internationalization, we're not actually doing anything for internationalization right now, which is not really an app issue. It's more of we want to be able to support and have customer support and community support for people in different languages before we actually introduce that into the code, obviously. So totally. It's more of an issue of having that piece first. And the second one was, sorry.
Server-side rendering?
Yeah, so we're not doing any server-side rendering for this app right now, which is something that we will have to do eventually. But this app is grown out of basically an older app, which is a Rails app, which we still serve to crawlers. For instance, Facebook, we want to have the open graph tags, so we serve that to them. For Google, actually, it's been interesting. We've seen, if you Google SoundCloud results and look at the page preview, they're clearly on the single-page apps, and they are actually caching and indexing them, some quite well, and some not so well. So I think that we want to explore some solution in the future where we can render these just for bots. But right now, we're not doing that.
Okay, thank you.
Yep.
Hi, thanks. The talk was really good. It was very helpful, especially for coming from Backbone and
Cool.
getting started. One of the questions I had was the view that you showed as an example had a very declarative syntax. Is it really that declarative, or do you have a bunch of functions under there for responding to events. And then also, I saw you were packaging CSS and templates in there.
Yeah.
Is that something you do everywhere, and how does that actually get bundled in when it gets deployed?
Yeah, sure. So as far as the declarative, I mean, it is pretty declarative. Yeah, I mean, like a lot of the, like for instance, if you have a collection that you've included in setup, you already get some events bound, and then the prototype would have on click, on whatever, or the standard event hash that Backbone uses. So most of it is pretty declarative. We also have a mix-in system that I didn't go into, but that helps kind of make some of that transparent. And for the second, sorry, it's the second question. Yeah, so packaging the CSS. So yeah, we're requiring it there, right? So we have this in our dependency graph, so we can actually look and see which CSS we need, and then we just bundle this together in order and put it into the DOM. And we also have a build step that makes basically a base CSS file out of everything before it goes out. So yeah, putting it working with CSS in that way is really nice, actually, I would say. Like where you have each view has a JS file for the actual view constructor, or the view class, and then you have the template and the CSS, and they're all kind of they live in the same place, and their concerns are very much only about that exact view. So that's how it goes. There's more information on the CSS actually in that blog post about building the next SoundCloud. Cool. Thanks.